Okay, we'll go ahead and call things to order for today. It's the 13th of January, 2026. Welcome to Open Research Institute's Projects Meetup. What we do at this meeting is we talk about what we've done over the past week, what we have planned to do over the next week, and if we have any roadblocks, anything that is getting in our way of doing good open source digital radio work, and if we need any resources that ORI can provide. And I will hand the floor over to Paul to give us an update. This is an Opulent Voice lab call update. The floor is yours.
Okay, hopefully you can hear me. Good. You're hearing me over Opulent Voice. We've made a lot of progress in the last week, and we're able to transmit and receive voice audio effectively. We're still on a cabled up system here. In order to do that, we had to have received the new Libra SDRs, and they came almost a week early. So we now have three. Then one we've been working with for a while now, and two new ones. Right now I'm using the two new ones. One of them is transmitting, and the other is receiving, and the received data is going into Zoom. So you're hearing me over Opulent Voice using this microphone instead of my regular microphone, because this one has built-in USB. So I can plug it, I can plug it directly into the laptop and use it as an audio source. And with a little bit of trickery with a Mac app called Loopback from Rogue Amoeba, one of my favorite software company names, I'm able to route the audio from Opulent Voice directly into Zoom. So there's no microphone speaker coupling or anything like that. Hopefully it sounds good, and we'll work on making it sound better. I'm probably might be a little too close to this microphone from time to time. So if you hear it break up when I talk up real close, then that's my fault for talking too close. I'm sure Michelle can give a better rundown on what all we've actually accomplished in fixing it so that it works this well. So I will pass it back to her.
Okay, yeah, thank you. When last we met, we had, I believe, had a build that crashed the Libra SDR. And that day we figured out what was going on, and then we resolved three or four other bugs that were preventing the receiver from working. So over the past month or so, we've spent most of our time trying to debug some very frustrating issues with transmit, moving from CMOS interface to LVDS interface, moving from the Pluto SDR 7010 Zinc to the Libra SDR 7020. And we were able to deliver working loopback radio. So the protocol will need to be updated. We did find out some things and improve some things. Our just random number randomization has been replaced by a better linear feedback shift register. This is a particular pattern from CCSDS. And we decided, yeah, that's going to be more efficient and more repeatable than just a random number, a set of random numbers that we generated from MATLAB a while back. The interleaver is still the row column interleaver that is proven to be pretty optimal and good for us. And we did check out a lot of things with our half rate Viterbi encoder decoder, the forward error correction, and we added a note about the tail bits. So we do not process the tail bits. There's 6 tail bits on this particular encoder, and we catalog the very minor effect that has on the frame error rate at edge conditions, and that's in the source code. So that's in the header. So this was a huge step forward. So we went from loopback right after our last meeting. The loopback worked back to the, looping from your transmitter to your own receiver on a single radio. And that's a very powerful and important test to do. But because you're transmitting and receiving from the same hardware, you really don't exercise the synchronization in a way that you would in real radio. So getting additional radios was a big deal. We thought that was going to take a lot longer than it did, but as Paul mentioned, two arrived, and he turned them around and configured them pretty quickly. And it works over the air as well. So all of the work that we've been putting in, and all the things we've been dealing with, and the refinements we made, and going back to theory and making sure that we have the best possible design really did pay off. So I think we're really close to having a full, what we call a lab call. So that's from one radio to another. It's either going to be conducted or, over wires or over the air. In order to sort of do this over the air, we really do need to look at the amplifiers and the filters, and comply with all the regulations for emissions. So I think when we have the lab call, a formal lab call, that we'll be doing this conducted, that it'll be over cables in the lab. And if that hasn't already happened, then it will happen very, very shortly. So that's another big milestone. So we're talking about two pretty big milestones in the past week. Um, and yeah, this is solid good news, and we we'll continue to publish through the newsletter and through articles like to QEX about the progress and what it took to get here. But the sort of the lab call means that we have over the air radio links working, and we can start talking more about integrating this into the satellite system to Hyperia, and what it takes to receive multiple frequency channels. So each of these radio links, Opulent Voice transmitted up to a receiver in a satellite or in a ground sat, a terrestrial node, and then that is processed into the frames that go on the downlink, which are DVB S2 or S2X frames. And so that's a whole other category of work that we have a pretty good theoretical handle on, but we don't have a demonstration yet. And so that's I think that covers everything. Is there anything that I'm missing, Paul?
Well, there is one thing that we need to admit in the interest of full transparency, which is that we're still trashing the first frame of every transmission.
Oh yeah, yeah.
We think we know what's going on with that, but in the meantime, that means short messages can't be sent because the first frame includes the message. The rest of the transmission is just dummy frames. Um, and it also means that the recording of voice is prevented because the first thing that comes out is the signaling message that says, okay, here's going to be some voice. So playing back in Opulent Voice or in Interlocutor's user interface doesn't work. Uh, I'm only able to talk to you here over the air, because once the first frame has gone by, all the other frames are received successfully. And so I only lose 40 milliseconds at the beginning of my voice transmission. But that'll have to be fixed. We think we know what to look at for that. We haven't tried it yet.
Right. Yeah, thank you for the reminder. It slipped my mind. But yeah, the first frame is reliably full of garbage, and I think I know why, and it is fixable. So the addition of soft decoding requires or doesn't require, but the way that we do this is that we went from a hard decision, like forward error correction, to where you just make a call, zeros or ones. And then we now include soft information or the confidence about each bit. So in Dungeons and Dragons terms, this is like knowing whether or not you hit an opponent or not. So hit or miss. That's the hard decision. But if you knew that you had come really, really close to successfully hitting your opponent, you rolled a 19 and you needed a 20 versus you rolled a 2, that actually helps. You now know whether or not you're super far away and you need to change tactics, or if you just need to keep trying. So that's what we've added. And when we did that, we have a stream of soft information in parallel with the hard decisions. Both of these things already come out of the demodulator that's provided to us. So the MSK demod from Matthew's work already provides all of this. We didn't have to concoct it or calculate it or do anything extra. We just had to use it. So in using it though, what I did was something not exactly perfect. Uh, I set up an array for this and didn't really think about this. Everything else needs to be buffered because of the 40 millisecond, frames coming in. So what looks like is happening is that we're overwriting, where you get that first frame of soft information and we start on the second frame and we just overwrite it, we then deliver that mess as the first frame. And then every other frame works because of AXI, the pushback and the handling of things. So it all works out after the first frame. So this is very fixable. We have good like ping pong style buffers everywhere else. I just didn't really think about that. This is actually something that's too brittle. So that's the first thing that I'll do next time I'm back in the lab is to try to make that a better design, and then we'll go and test it. And if that doesn't solve it, then we'll keep digging. So yeah, thank you. That is a big bug right now that we have, but I'm very confident that it was me just being a little too naive about the arrays and handling the soft information. So that should get worked out soon. All right. Any questions about anything that we've said so far? Anything about Opulent Voice? Okay. And then Aaron, if you'd like the floor, it's yours to take.
Sure. Congratulations. It's super exciting to hear that we got the modem working and the audio quality sounds great, Paul. So I'm working on the high Faria piece, and I was able to squeeze out some time on doing so. So one of my main goals is to get GSC through the encoder and on to get to the point where we can demonstrate this. So I worked on the CPU side, a small application that will generate GSC null packets that I can feed the encoder with. And so I got that working and built for both 64-bit and the ARM and ARM 64. So two architectures. OpenCPI allows you to cross-compile it easily. And I got it feeding a file and making sure that it matches similar. Basically, I took what Evariste had on his implementation and just extracted all the code required to get the null packet. So I have a null packet on the HDL side on the encoder. Previously, I didn't have an input.
What?
Anyway, I didn't have the input implemented, so I implemented the 32-bit input to the encoder, and then I hooked it up together. So I generated a bit stream. So the next step is to actually test it. So I have a simple application that will configure the registers on the encoder on the HDL side, and then enable the null packet generator to generate the GSE, and hopefully I can get something that the encoder is happy with, and to get DVB-S2 frames spit out the RF. So that's what I'll be working on this week, testing it. I'm sure it's not going to work the first time, so probably debugging it. May have to include an ILA or two to see what's going on. But that's where I'm at.
Fantastic. I'm very much looking forward to this. It's a lot of heavy lifting. Thank you so much.
Mm-hmm.
All right, and I see Evariste. Evariste, you have the floor. If you'd like to talk about anything over the past week or coming up.
Okay. Very great news that all this debugging is now working. So it's great. I try to make the same design as you with the MSK HDL in my toolchain. I can maybe share some just don't know if I can share. Yes. This one. Okay, so I don't know if it is working. Yeah. This is system BD. So normally it is by cards, and I have now a complete system, which means that I can easily compile the same bitstream over several platforms. So you mainly work on the Libra SDR, but there is a lot I can support, and it's easy to integrate some components. So here I have here the MSK TCL, which is separate from the PS7 from oh sorry. So you have different TCL depending on the board and what you want to do. So on my design, you can have the MSK and Maya, for example, at the same time. Okay, all this bitstream could be after that integrate in Debian-based, which I called Zuckerni Hooper, and then you can see here. Sorry, here. So here I have a Debian 1, and I have just compiled the Dialgus just on the board directly, okay? Because as I am in okay. Well, I am as like I am in a Raspberry Pi, so it's a normal makefile. Here's I don't have to cross compile, and yeah, then so I can then use the bitstream I have in Dialgus. So I think it's this one. And for now, I get, I hope, what it should work. But the problem now is I don't know how to step forward because of the interlocutor, which is not very clear for me because as you need at least two audio USB set, as I understand, and well, that's not very clear. So I am at this state. I have a parallel bit stream. So there is another branch on MSK firmware, which is not very different, but you have to clone under my HDL from my repository, and then it works. Yeah, so that's where I am. On the other side, thanks to Aaron to work on the DVB-S2 and GAC. If you have any question, I know that you analyze my code repository, but you can ask any question you want, no problem. So the GAC on with the DVB-S2 is working on my firmware. Be careful, it's not possible to mix transport stream and GAC. So null packet, well, I don't know what you mean by null packet, but null packet is generally in transport stream, maybe you say some padding packet in GAC, but
I didn't mean padding. Yeah, the padding packet.
okay, padding packet. Okay, great. um, and so yeah, if you have any question, let me know. I can easily answer to you, even on Bitstream, because on the Bitstream, I think that I have a commit which is not on the repo in order to change on the fly the FEC, but it will be maybe uh, another stage.
Okay, sounds good. Thank you.
Yeah, and after that, or in the overall project, thank you very much, Michel and Paul, to describe the project with all the dry EO. It's clear, and I have some question about that, and I have some just a naive question. And I know that if on the conference at FOSDEM, if there is some question on that, I want to be sure to answer about 80% of the question. So maybe I have some naive question, but it's good to clarify all that.
Yes. Yeah, we'll do all we can to answer everything. Ask away, and I'll keep working on the drawings, and I'll move them to where they're more easily seen in like a slide. If there's any format that you would prefer, like if there's a slideshow format that you would like, then I can start doing that today, moving those things from the draw IO into more easily usable graphics, and breaking out the text in just text. And then yeah, answering any questions. I think I can make some more drawings to show what we think the right way to like, okay, here's interlocutor, and that's what you're running on a computer, and that targets the dialogus. So dialogus and the modem are on another device, and so it's just a IP address that you would target. So that's kind of the idea. They can all be on this. They can't. Everything could run on one machine if you had the ability to, to load up a bit file and to run dialogus on and also run interlocutor. That could happen all on one. But we kind of did this because it's more easy with the development boards that we have to have the nice graphical user interface and the Python scripts of interlocutor generating, collecting your voice and your text and handling that, and then just sending the frames over an internetworking connection over IP address off to Dialogus and the modem. So that's kind of the idea. And I'll draw some more things and make that super clear. So that's just how we decided to split up the job. The user interface and the creation of the baseband data frames, and then Dialogus and the FPGA handle the processing and the creation of the modulated frames.
Yeah. Okay. Just for testing, I know that the tool is not existing right now, but could be good to just have the output of interlocutor, maybe a recording of what could be maybe 30 seconds of voice
Yeah.
in a UDP frame, which you record, and then playing in loop just as a file.
Yeah, I think
with
maybe like a PCAP file might.
Yeah, exactly.
Okay,
Well,
yeah.
it could
Good
be a
idea.
PCAP file, but it could be also yeah, just a file with, we know that we need to send it every 40 milliseconds. Okay, that's right. So we get the frame, send it and wait and etc. It's just an easy way to test the modem without having the another process running. But
Right. Good idea. I agree.
okay.
Yeah, very good. This is fantastic. Yeah, so yes, FOSDEM will be the 31st of January and the 1st of February. So coming right up. And thank you very, very much to Evariste for agreeing to present our work. And are you're all, do you have another presentation that's
Yeah,
scheduled as well for Tezuka that you're going to be able to talk
yeah,
about that?
exactly.
Oh, good.
Yeah, on the afternoon. So Jean-Michel think that, well, firstly, he put the two presentation at the one after the other, and I say, wow, more than one hour
Yeah,
is a
that's a
lot for
lot.
me. Yeah, yeah.
Yeah.
So I prefer to split it, but as there is some kind of thing which is in common, which means that showing that we can have the dialogus directly working on the library on a Zinc one and having a Debian based is very useful as soon as you have an SD card, and so it's complementary. So the first will be opponent, but saying that it could be integrated in the next project, well, in another project which is more global, and yeah. So yeah, two there is two presentation to do.
Wow, thank you. I'm really looking forward to watching both and all of the other things going on at FOSDEM. It's a big show that covers a lot of ground. And you have presented there in the past about previous work. So you're well known to the audience there. And
Mm.
yeah, thank you
Not
so
not
much.
not really at FOSDEM. I presented at SDR Academy,
Oh,
but
okay.
not at FOSDEM. So, but we already speak a lot with Jean-Michel. Yeah.
Very good. Yeah. Well, thank you. Thank you very much. Looking forward to it. And I can't wait to hear how it goes and all of the people that you will meet. I did ask around to see if anybody else from FutureGEO would be there. And so a lot of our work is applicable and will hopefully be used in the future GEO endeavor. And this is a GEO or HEO amateur radio effort sponsored by the European Space Agency. And AMSAT DL, the German AMSAT, is leading up. They've been selected sort of to be the central body, central organization, kind of organizing and making things happen. They're the ones that sponsored the workshop back in October. They run the forum for FutureGEO. So I did ask around to see if anybody would be there at FOSDEM, and I'll keep asking and just let folks know to catch you at the show and maybe make some contacts there. You probably already know everybody that would be involved, so it's the usual technical folks in amateur satellite or amateur digital satellite. So what
Good.
we're working on is so for Future Geo, they are interested in prototypes and demonstrations of exactly what Evariste is doing, exactly what we're doing, exactly what Aaron is doing. This is the sort of stuff that they really want to see and to help us uh, get this stuff into space. So there's no launch scheduled, but there is a lot of opportunity here, and ESA is very interested in helping work things out with commercial folks and to try to find a way to get more amateur radio and more open source work into space. So we're looking forward to the rest of 2026. It should be a really good year for showing stuff. The next event may be in March. That's very early stages of planning. The FutureGEO folks and the ESA would really like to have everybody meet up at an event that's already on the schedule and not to make people travel to yet another event. So they're looking around, and the earliest it would be March. So that's what I know so far. And yeah, looking forward to FOSDEM. It'll be great. And yeah, doing more demonstrations. Okay, so the floor is open. I see Mike Parker is here. Welcome, Mike, and Rick is here. And so the floor is open for you all if you'd like to share anything related to anything that we're doing or something that is open source digital radio, space or terrestrial. And the floor is y'all's.
Their audio is working now, I hope. Yeah, so hi everybody. This sounds exciting about what you guys have achieved. I've been working with the University of Arizona on a satellite known as CatSat for a number of years, and we're to the point now where the University of Arizona team has opened the CatSat up to use by anybody in the 5 and dime mode through a 200 kilohertz wide linear repeater. So if anybody has the capability of the desire to go through a real satellite that's on orbit, help yourself. I and other people can certainly supply information as to how to do it. And they launched a satellite. Part of the justification for launching it was the ham radio support. And so we're trying to operate in this 5 and dime mode now, and it seems to be working. So far, I have a station that's has two dishes, both a meter in diameter, and it's a low orbit satellite, so I have to follow it. We get about 10 minutes of horizon, above the horizon per orbit. That's a valid pass. And the result has been that just in the last couple of weeks, I've been able to send my station call sign, KT7D, in CW through the satellite. And so everything will work, presumably. Prior to this, for the last year, the satellite has been sending telemetry in DVB-S-B, S2 rather, and that's been very successful. We typically come down on our downlinks to our ground station, which is a 6-meter dish for that, at about several megabits per second. So that's really all I had to report. I have a question. There have several people interested in the voice that you guys are working on, and the Pluto Plus. I thought you guys were going to migrate to Pluto Plus boards, and so we have a couple of Pluto Plus boards, but it sounds like maybe we need Libra boards. Is that right?
I think Paul might be able to answer that because the Pluto Plus and the Libra SDR are pretty close. Do you want to take that, Paul?
Well, there are a whole bunch of different boards that are called Pluto Plus. I bought one, this one here, that's only a 7010. So that won't get you there with our current software. It's a little bit too big for a 7010. If you can find one that's a 7020, it would probably be possible to port to it. If you tell us which one you're interested in, we might be able to help. Evariste knows more about these individual items than I do. Let me reach over here for a second. This is the Libra SDR that we've been buying. These are available. It's got a couple of attenuators sticking out, so the transmitters don't ever transmit into an open. This is about $150 right now on if you buy from AliExpress. So this is a good choice. You can use this plug and play with our current software. Any other version of the Pluto Plus is probably going to be a porting effort. Maybe a little one, maybe a big one, depending on what all is different.
Yeah, the things that we found were different going from the Pluto SDR with the CMOS interface and then moving to like the Libra SDR with LVDS. And that required some changes. The other big change is that the sort of the pin constraints. So if the team that did the particular clone picked different pins for, then that has to go into the pin constraints. I mean, but those things are, these are solvable. And Evariste for sure has dealt with this directly in his Tezuka effort to bring up all these different Pluto clones. So he has a big head start here, and I can see some boards on his desk. So it depends, Mike, on exactly which Pluto Plus, because there's a whole family of them. And, just let us know, send a picture or the details on the exact board, and we might already be matched up. And I'll let Evariste take it from here.
Okay. Just for information, this is the Pluto Plus, the original Pluto Plus, which is a 710 FPGA. And well, it's like a Pluto, but with just the gigabits and SD in more. Then you can have this kind of boards, which is not a Pluto Plus. I call them fishbowl because it was the original firmware, which called like that. You can find it now at around $120 or $100, and it's a 720, and it's TNI compared to the Pluto Plus. So this one is my favorite for now, 72, and after that, the problem with the clone is that here you have Libra. Oh, sorry, this is normally a Libra SDR, but it is a zinc SDR, so it is a clone of this. And the original one is this one. Sorry. I don't have a lot of. This is the Libra SDR. So some have some VC260, some have only. Oh, sorry for my garbage. And so there is a lot of clone. Effectively, Tezuka is handling all that, and that's why I demonstrate that I go with MSK on the Libra there, but I can generate on all the other as soon as it is 7020.
Well, thanks a lot for the information. And I'm sure that it'll be weeks, if not months, before we really get into this. It's a little bit of a new field for us. So at that time, I'm sure I'll be calling several of you and boring you with questions. So thanks a lot for the answers now.
Yeah, sure. Yeah, just I think probably the only Like the first detail is to look at the size of the FPGA. So the 7020 is where we're at, and the 7010 is too small. And that's really, and then from there, we can help you out whenever you're ready. Cool. Okay. Well, Rick, you have the floor if you got anything to talk about or any questions or floor's yours.
Okay. I've been very busy lately preparing for the Deep Space Exploration Society's involvement in the Artemis II manned space mission to the moon. We have tentatively been invited to assist in tracking the progress of the manned space capsule by tracking the carrier of the telemetry and recording and the Doppler shift of the carrier as the spacecraft moves to and around the moon, and reporting that to NASA in real time. They won't let us decode the telemetry. That's encrypted and classified. We do think we can demodulate the telemetry, but I'm not sure what good that would do if we can't decode the bits. So we're concentrating on what they asked us to do. So the two key elements of this project are the RF, which includes a V210 SDR and preamps and feeds and so forth for the antenna, and a precision time and frequency reference system, which I'm designing based on the equipment I normally provide to NASA's Very Long Baseline Interferometry systems around the world. We're downsize it a little bit. We're not going to have a hydrogen maser, but we will have a HP 5065 rubidium source, which I think is the best rubidium that was ever manufactured. And that will be calibrated to GPS, but not steered, because we don't want steering artifacts to influence the Doppler measurements. So we will be we'll be calibrating the system to GPS and then measuring the offset of that is the error term during the mission, by using the same GPS equipment and recording it and then subtracting off all the error terms as we send the data to NASA. So I'm pretty excited about this, and we managed to get the equipment that I had previously had installed in a company in San Diego. They have donated all that equipment to DSES, and they drove it here to Colorado Springs, which was a 4-day round trip for them. That was part of the donation. And I have part of the equipment sitting here on the bench, and we are actually designing circuitry in real time. And when I say real time, I do have professional tools for doing schematics, but we're doing things on the back of envelopes like everyone else does, and then transferring it. So we have some interesting circuits that we're designing to add to this system, and it's all working out very nicely so far. It's a big project, and it's kept me away from FPGAs and fun Opulent Voice projects, but I at least can listen in once a week to see what I'm missing on this project while I'm working on the other one.
Yeah, it sounds like a big deal.
Just Rick, I just have, it's not very far from the FPGA, as I have a request from a French amateur radio running a 6 meters dish and joining the NASA project and ask me, and they choose the Libra SDR in order to measure the Doppler, and they asked me how to have a precise external clock, and this is the real well the pointing, well, the process, which is not the easier, but they try to do that with the libraries there, so the same platform we used right now.
Yes.
Wow.
There are many ways to do precision time and frequency that are much less expensive than what I'm doing. I actually do that for a living, so I had some spare equipment available for DSCS. But if they need any uh, advice, they're welcome to contact me. There's a variety of emails, including the one that's on QRZ.com at my ham radio call sign K0GD.
Okay, thanks.
Yeah, looking forward to hearing how that goes. That's I know that there's a lot of stations out there that are gearing up.
Yeah, the difference is a lot of stations have heard about this and they want to participate, especially universities, but only a handful of stations have actually been asked by NASA to be their partners, and DSCS is one of those.
All right, any questions or comments?
Rick, what would be the best way to follow up on and get more information about this NASA program that you talked about? Is contacting you the best way, or is there some other better way?
NASA has a web page all about this Doppler measurement program for Artemis II. I don't remember what the web page is right now. If you can't find it, send me an email and I'll find it for you.
Okay.
You can also look on the DSES webpage, which is dses.science. I had under projects, there's a whole write-up about the Artemis II project that we're talking about here that might answer a lot of your questions.
Okay, thank you very much. This is a little bit of deja vu. I did my thesis on bouncing radio waves off the moon from Apollo telemetry signals.
Oh, okay, good.
So that dates me.
That's very cool.
Thank you.
I know that there was a call for participation, which probably a lot of us are listening to this are familiar with it. I think it closed in October, but the technical details and the work that is done by the open community, probably the most notable contribution and walkthrough was from Dr. Estefes, and this was a Artemis 1, and so not Artemis 2, but the amateur observations from that that are very well documented, and he's got some really good walkthroughs and explanations of it. Now that's the signal, the information signal. So the focus on tracking the Doppler is a whole lot easier and can be done with a much smaller dish. But if you have access to a larger dish and you want to take a crack at it, it has been documented, and it's not expected to be very different from that. And it's got some things that are very familiar to us, offset quadrature phase shift keying or OPQSK, I think was the was the thing, and LDPC encoding or low density parity check stuff, and lots of CCSDS things. So there is a lot of information there if you want to take a crack at actually demodulating it. The decoding of it, if it is encrypted, then well, then it's a little harder of a problem. But it's something that if you're up to the challenge and you have a large enough dish to recover the information is a super engaging and very cool thing to do. So if you need direct links to Dr. Estepez's work, then what I'll do is I'll track it down and send it out. So yeah, that's neat stuff coming up. All right. Any open floor for any sort of questions or comments? Anything you want to share or follow up on?
Just a quick question. I think that you have two more Libra SDR at Remote Lab. Is it possible to have one on site in order to test the firmware with the Tezuka and try to make some tests, which means that um, uh, trying to get the bitstream plus the firmware and using it from your interlocutor, going from your firmware and on the Tezuka firmware and try to see if it's relevant. And so, yeah.
Yeah, that sounds like a good experiment. I was thinking that exactly that sort of attempt when you showed on your screen um, everything compiling. So it occurred to me that that should work. So I'll defer to Paul, who is in charge of the in charge of the lab. I should probably not promise something that I should probably not leap ahead. But yeah, go ahead, Paul.
Not sure I quite understood what you're proposing. Can you go over it again, please?
Yeah, the purpose is to have a Libra SDR on the remote lab, which I can update firmware through the SD, just by SCP on this. And with this firmware, which is running in parallel to another firmware you have, and try to get interlocutor going to this Tezuka firmware or on the MSK firmware and try to see if both are working.
Okay, I think that should be possible. Um, we have um, three, and two is enough for the testing we're doing now. So we can put one online at the remote lab. Um, we would have access to the serial ports and and the Ethernet access as well. Do you how much do you need anything extra besides that, or just those network access ports?
Sorry, can you repeat the question?
Do you need anything besides access to the serial ports and the Ethernet port?
No. With the Ethernet, I can upgrade all the firmware, and if there is some issue, yes, using the debug one is a good thing, but that's enough. Yeah.
Okay. Yeah, I'll look into rigging that up as soon as I can.
Yeah,
That
I think
reminds
that
me of a
would be a
question
great.
I had for you. Sorry, Michelle, go ahead.
Oh no, I think it's a great test, and that would prove out how interoperable what we've designed really is. So I'm all for it.
Yeah, Evariste, I got these two new Libra SDRs, but they're not identical to the one I had before. Um, they're not physically identical. The engraving is a little bit different. That doesn't matter. but also I noticed that the debug port has two USB serials instead of four. And I wonder if that means I ended up with some kind of substandard Libra SDR, or if I should not worry about it.
Hmm. Well, this is mainly because they use a different FTDI chip.
Right.
Um, Usually, well, it's not very easy because sometimes they sell as Libra SDR, but it's maybe a fishbowl. So I don't know exactly. I didn't buy a library there recently, so I can't tell you exactly what happened. But definitely they changed the FTDI one, the FTDI chip for another one.
Yeah, I opened it up and inspected. It appears to be the same circuit board. It says it's Rev 5 on the back. Um, Looks like exactly the same thing, except that they swapped out. It's a FT 2232 instead of FT 4232. So it has two ports instead of four. But I think they were only using one anyway. So uh, maybe that doesn't matter.
As soon as your bitstream is running, which means maybe the FSBL, the boot.bin is working, then it's okay. Yeah, that's the main issue, and that's why SD card booting is very interesting because else when you flash on the well when you write on the flash and you have wrong boot, then you have to go to GTAG in order to remove that. And with SD card, even you make a wrong FSBL boot.bin, it is not matter. You just have to write another SD card and it works. So um, yeah. Mm, I'm interesting to see if it is really different or not, and if my firmware is still working on that.
Okay. Yeah, we'll
Well, ours
give it a shot.
ours did. We
Yeah.
just plopped it in to the new Libra SDRs, and they work the same as the old one. So except for having only two serial ports on the debug.
Um, Paul, could
Yeah.
you possibly be a little more precise about which Libra SDRs you just received? Because there's many Libra SDRs.
There are.
The only way I know to be more precise is to like give you the URL on AliExpress where I found it.
That would be
Um,
nice.
but that doesn't help really because I ordered from the same offering before and recently, and I got slightly different
Oh,
boards
yeah, but at
and
least
slightly
it
different
narrows
enclosures.
Yeah.
the choices down a little bit.
Yeah, understand. Yeah, never a
Uh,
dull
it,
moment with the supply chain.
that's right. I could try to do that while we're still here and put it in chat, or I'll send it to you if I
Either
don't meet
way,
that deadline.
Awesome.
Okay.
All right. Yeah, the just looking a little bit further forward, we'll be porting yet again to go to like a Hyperia style central node or satellite prototype. So we'll be encountering all of the things that we've discussed over the past weeks to months here. When we go to essentially a larger FPGA, we have I think a Zinc 7045 on one development board here in the lab, and we have a ultrascale on the other. And I believe that is the same board that Aaron is working from. It's not, if it's not the same, it's very, very similar. So we will be that's right over the horizon for us, is to take the Opulent Voice receiver and put it on a satellite, and also rig it up to where we are now receiving multiple parallel transmissions. So all of the porting the difficulties and the things that we're learning and getting better at porting, and all of that will carry forward, and we will apply that knowledge and hard-won experience to doing this yet again, at least once, to get a working satellite or ground sat for. So this could also be a terrestrial repeater for cool microwave amateur, but the main demonstration will be, it's intended for amateur satellite. So that's coming right up. We'll be starting to look into that and leveraging the work that we've done with the Theseus Core's polyphase channelizer, and doing more work to explain why that's the best choice, why it's so neat, why people should learn more about it, and to show how it works for us to turn a bunch of uplink channels into sort of organized and easy to use downlink. So that's coming right up. All right, any last comments or questions before we close?
I put the URL for AliExpress into the chat. Rick, let me know if that works for you.
Yeah, with
They're
the
down, they're on sale
caveat.
right now for.
Yeah, I got it.
Yeah.
Okay,
Yeah,
good.
it's fine. And
Yeah, just with the asterisk that, your mileage may vary, as it's true anytime you purchase something like this. It's interesting out there. And there's lots of choices. So the whole Pluto clone market is full of very interesting things going on. So all right, everybody. Thank you so much. This has been fantastic with so many different things going on. And if you need help, please get in touch. We're always on Slack. We should be back next week to meet again and to meet in person, give a floor for everybody to talk about what they've done and what they have planned, and to get roadblocks broken down and to spread the news on all sorts of interesting things going on out here in open source digital radio work. So again, thank you very much for all of the wonderful work that you're doing. We know that once you spend your time, you can never get it back, so it's priceless and deeply appreciated. And see you soon.